NASA just confirmed something truly extraordinary. Voyager 1, the farthest human-made object in existence, is once again transmitting usable data back to Earth, and this time it may be making history all over again. Launched nearly 50 years ago, Voyager 1 has traveled more than 15 billion miles from Earth. It's a relic from the analog era, yet it's now at the center of one of the most surprising discoveries in space exploration. Scientists are calling it impossible, a revelation that challenges what we thought we knew about the space beyond our solar system. So before we dive in, don't forget to like and subscribe, because the universe just got a whole lot stranger. Since crossing the heliopause in 2012, the invisible frontier where the sun's influence ends and interstellar space begins, Voyager 1's job has been to send back insights from this little understood cosmic region. That mission just took a dramatic turn. Voyager 1 has detected something no one expected, a persistent and organized wave structure within the plasma of deep space. This isn't just cosmic noise. Data streamed from the probe shows it passed through a vast oscillating band of charged particles, stretching hundreds of millions of kilometers. The discovery didn't jump out immediately. For months, tiny fluctuations in plasma wave data were dismissed as background noise, until patterns began to emerge. Pulses, repetitions, a rhythm where there should have been randomness. Initially, scientists feared a glitch. After all, Voyager 1 has weathered decades of cosmic radiation, and its 1970s-era instruments weren't designed for this kind of observation. But thorough checks proved it was no malfunction. The signal was real, coherent, and completely unexpected. For years, the interstellar medium, the thin space between stars, was considered a quiet, mostly empty place. Hydrogen and helium atoms, a few cosmic rays, magnetic fields too weak to shape anything meaningful. But Voyager's findings suggest otherwise. The interstellar medium isn't just active, it's organized. The frequency and structure of the waves don't match anything previously recorded. Not solar shock waves, not background magnetic turbulence. What Voyager found resembles a standing wave, like vibrations in a crystal. Except this crystal stretches across unfathomable distances between the stars. This changes everything. Theories of interstellar space built on emptiness and simplicity may need to be rewritten. If these waves are common, the space between stars could be a connected, resonating web rather than a lonely void. It raises big questions. Could energy and matter be interacting across light years in ways we've never understood? Is space itself more like a fabric with hidden patterns, resonating with unknown forces? Some scientists suspect these waves could be remnants of ancient supernovae, echoes from explosions long gone. Others think they may be the result of galactic magnetic fields colliding and reconnecting. Whatever their origin, Voyager 1 may have just passed through an interstellar memory, an echo of a cosmic event thousands of years in the making. But what if this discovery goes even deeper than we thought? Some scientists are daring to ask a radical question. What if these waves aren't natural at all? While the mainstream explanation still leans toward natural causes, the strangely precise and rhythmic structure of the signals has sparked quiet speculation. Could they be artificial? Could they be a kind of cosmic message? Imagine if intelligent life, somewhere out in the galaxy, chose to communicate not with light or radio, but through the very fabric of space itself. Energy pulsing subtly through the plasma between stars. If so, Voyager 1 may have unknowingly passed through such a message, its instruments catching a faint signal hidden in the silence. Regardless of their origin, these waves have already reshaped how we think about the outer limits of space. Voyager 1 is no longer just a lonely traveler. It's become a sensor on the edge of understanding, pressing into the unknown. It's as if a song has been echoing through the galaxy, unheard for ages. And now, finally, Voyager has caught the first few notes. The implications are staggering. If these structured waves exist throughout the galaxy, they could shape everything from the motion of energy to the formation of stars. These patterns might even guide how cosmic rays move, or act as early sculptors of star-forming clouds, gently nudging gas and dust long before gravity steps in. With this new perspective, scientists are rethinking how matter moves and transforms across the galaxy, from the moment it's blasted out by dying stars to the time it's reborn in stellar nurseries. The discovery also forces us to revisit our own solar system's edge. The heliopause, the supposed boundary between solar and interstellar space, may not be a hard edge after all. Instead, it could be a blending zone where the sun's influence and the interstellar environment overlap, interact, and surprise us. If plasma waves can flow in organized patterns out there, then maybe the solar system is more open than we thought. Perhaps energy, particles, and even information are constantly moving between our corner of space and the wider galactic environment. Engineers are equally amazed. Voyager 1, with technology built in the 1970s and less power than a household light bulb, is still returning precise, groundbreaking data. Its plasma wave instrument, originally meant to study planetary fields, is now detecting deep space phenomena far beyond its intended capabilities. This incredible success proves the lasting value of long-term space missions. It also shows how rugged, flexible design can unlock discoveries we never planned for, paving the way for future missions to explore even deeper into interstellar space. But beyond the science and engineering lies something deeper. Voyager 1 is a time capsule of human hope. Built in an era of analog tools and starry-eyed dreams, it continues to show us what's possible. That something so old, so distant, could still uncover something so profound reminds us. Exploration isn't just about what we find, it's about why we keep reaching. It turns out the universe still hides wonders in the most unlikely places, and sometimes it's the oldest tools that uncover the newest truths. Voyager 1's unexpected findings are sparking fresh conversations about interstellar communication. SETI researchers are now rethinking long-held assumptions. If plasma itself can carry complex information, whether natural or not, then maybe we've been searching in the wrong places. Instead of signals in light or radio bursts, what if the messages are hidden in the very structure of space, not shouting across the cosmos, but whispering through the interstellar medium? Voyager, launched decades ago, may have picked up the first hints of that possibility. Whether it's a natural phenomenon or something more intentional is still unknown, but the potential is staggering. Now, astronomers are comparing its data with other spacecraft. Voyager 2, traveling on a different path through interstellar space, hasn't found the same wave patterns. That might mean the structures Voyager 1 detected are unique to its region, or maybe Voyager 1 is simply better positioned or more sensitive to catch these cosmic ripples. If these waves are more widespread, future space missions could be equipped with instruments designed specifically to detect and map them, charting a new layer of the galactic environment we never knew existed. Theorists are equally energized. They're running new simulations of plasma behavior under conditions we can't replicate on Earth. What was once a niche field, interstellar turbulence, is now taking center stage in astrophysics. The patterns Voyager 1 found echo ideas from quantum science, Bose-Einstein condensates, and early universe phenomena. Some scientists even think this could be a faint trace of events dating back to the birth of our galaxy. For physicists exploring deep theories like unified fields or links between gravity, electromagnetism, and quantum mechanics, this could be the first real-world data to test those ideas outside a lab. These waves might be nature's own signature, the hidden script behind how the universe runs. There's something poetic here too. This discovery didn't come from a sleek, high-tech observatory or a brand-new billion-dollar mission. It came from Voyager 1, a spacecraft launched when disco was in style and home computers didn't exist. Once seen as a fading relic, Voyager is now proving to be a fountain of insight, not just traveling farther than anything before it, but diving deeper into the mysteries of space. And it's not over yet. With every signal it sends back, scientists wonder, will Voyager encounter more of these mysterious waves? Could the patterns grow more complex, pointing to regions of higher energy or stranger behaviors of matter itself? There's even a slim electrifying chance that it may pass through a region where space behaves in ways that defy today's physics. Voyager's course can't be changed. It will keep drifting, powered only by momentum and memories of ancient flybys. But the space ahead is anything but predictable. This discovery shows us that the universe isn't quiet or empty. It's alive with structure and secrets waiting to be found. Not with a bang, but with a whisper. One that Voyager was just patient and lucky enough to hear. What it has uncovered, a structured, coherent and deeply puzzling phenomenon in the interstellar medium, has set off a wave of curiosity across disciplines. Scientists from far beyond astronomy are jumping in. Plasma experts, signal analysts, quantum physicists, even linguists. Each is now trying to decode what might be hidden in those hums and pulses, and whether they're part of a message we've only just begun to hear. At the center of this mystery lies something astonishing. Voyager 1 seems to have entered a region of space that isn't just reactive, it might actually be communicative. Instead of simply responding to cosmic events, this part of space appears to oscillate on its own, as if following some deeper rhythm. These patterns suggest laws at work that science hasn't yet fully understood. What if Voyager 1 isn't just floating through empty space, but interacting with a vast hidden architecture? The plasma waves it's been detecting might not be random. They could be sculpted by immense, invisible forces, like galactic-scale magnetic frameworks or flowing interstellar currents shaping space like currents shape oceans. This idea is gaining serious attention, especially among experts in magnetohydrodynamics. If magnetic fields thread through the galaxy in long, filament-like or lattice structures, then it's possible Voyager 1 just brushed one of those energetic lines, like a wind chime catching a cosmic breeze. The signals it recorded may be just one note in a symphony resonating across space, and if more of these resonance points are out there, they could be spaced like stations on an interstellar frequency dial, a galactic harmony waiting to be mapped. This also raises big questions about time. Could these structures pulse with a rhythm tied to the galaxy's spin, or cycles of star formation? Voyager 1's instruments picked up a temporal regularity that was never thought possible in such a diffuse, distant environment, suggesting a long-lived, self-sustaining wave system, a kind of interstellar heartbeat. Now, scientists are combing through past mission data to find supporting clues. Voyager 2 hasn't detected the same waves, but that might be due to its trajectory or instrument orientation. Researchers are even reanalyzing data from old probes like Pioneer 10 and 11, hoping to spot the faintest echo of this newfound phenomenon and help triangulate its source. Even the concept of interstellar weather is evolving. These plasma waves might influence the movement of particles across vast stretches of space, creating paths or currents that guide high-energy particles like cosmic rays. That could help explain puzzling arrival patterns of cosmic rays here on Earth, something that has stumped scientists for decades. This discovery could also revolutionize space travel. If deep space is filled with these invisible wave patterns, each with its own electromagnetic fingerprint, future spacecraft might be able to ride them, just as sailboats ride the wind. It opens the door to propulsion systems that use space itself as fuel. No engines needed, just a good sense of direction. And speaking of direction, what if these waves could guide explorers? Just as sailors once used the stars and ocean currents, future missions might navigate by reading the texture of space, the amplitude and frequency of interstellar waves. Voyager 1's findings could serve as the first draft of a new kind of star map, a cosmic compass written in plasma. Then there's the biological angle. Until recently, deep space was seen as barren and deadly, too cold, too empty to support life of any kind. But if some regions of space hold steady, long-lasting energy patterns, they might offer microenvironments of stability, small energy-rich oases drifting in a vast cosmic desert. That opens new possibilities for theories like panspermia, the idea that life, in microbial form, might hitch rides across the galaxy, preserved by and perhaps even carried along these plasma corridors. Some scientists believe that life, especially microbial life locked in frozen shells or dormant spores, might be able to drift through space, shielded from the harshest conditions. If plasma waves in interstellar space can concentrate or transfer energy, they might act as cosmic preservers or accelerators, giving new weight to the panspermia theory in ways no one previously imagined. But the implications go beyond biology. If these plasma structures are stable or cyclical across thousands or even millions of years, they might serve as a kind of archive, preserving the memory of the galaxy itself. Like the rings of a tree or layers of ancient rock on Earth, the interstellar medium could hold signatures of distant events, dying stars, magnetic storms, or galactic collisions. In that light, Voyager 1 may have done more than discover something new. It may have stumbled into a fossil written in plasma. This shifts how we think of the spacecraft. It's not just an ambassador to the future. It may also be a reader of the past. Physicists specializing in information theory are especially intrigued. The patterns Voyager 1 recorded, neither chaotic nor perfectly regular, resemble low-entropy signals, the kind that often carry meaning in communication systems, whether digital, biological, or artificial. If that's true, it opens the door to a bold idea. That information might be encoded into the interstellar medium itself, not transmitted through light or radio, but woven into the very vibrations of space, waiting for a listener. With that possibility in mind, scientists and engineers are racing to develop better detection tools. New instruments designed to read plasma oscillations in high detail are being proposed for future space missions. Even ground-based telescopes may be upgraded to detect these structures indirectly by watching how they affect cosmic rays or background radiation. Some research teams are even trying to recreate these interstellar wave conditions in laboratory settings, a difficult task, but one with potentially groundbreaking results. Beyond science, Voyager's discovery has touched something deeper in human culture. Around the world, artists, thinkers, and dreamers have begun to imagine space not as a cold void, but as something alive, something dynamic and interconnected. If space itself moves with rhythm and structure, maybe it isn't as silent or empty as we once thought. Maybe the universe hums with a harmony we've only just begun to hear. This challenges one of the long-held doubts about intelligent life in the universe, that if they were out there, we'd have heard from them by now. But what if they don't communicate with light or sound? What if civilizations have learned to inscribe messages directly onto the plasma fabric of space? Voyager 1's signal isn't confirmed to be artificial, but it's already changed the conversation. Instead of pointing antennas, the next generation of SETI may deploy plasma wave sensors to listen in on the deeper whispers of the cosmos. In response, universities and research institutes are launching new collaborations, bringing together plasma physicists, AI experts, and astrobiologists. Some are even exploring whether this discovery could help reshape theories about dark matter or quantum-level communication across vast distances. These ideas are still evolving, but they highlight just how far-reaching the impact of Voyager 1's data may be. The public has responded with wonder. Museums are building immersive exhibits to help visitors experience what these waves feel like. Schools are updating their science curricula. And Voyager 1, already a symbol of endurance and curiosity, now carries new meaning. Proof that even across the silence of deep space, there may be a story waiting to be heard. The Voyager 1 spacecraft has become more than just a scientific tool. It's a symbol of human wonder, curiosity, and the quiet pursuit of the unknown. What makes its latest discovery so remarkable isn't just what it found, but how it was found. There were no grand alerts or headline-grabbing flashes. Instead, it came as a whisper, a series of faint modulations, tiny shifts in signal strength and tone, detectable only through relentless patience and attention. It's a powerful reminder. The universe rarely shouts. Often it murmurs. And only those who truly listen can hear its most profound truths. Now, new missions are being envisioned to follow Voyager 1's path. Missions equipped with advanced instruments designed to not only confirm its findings, but to create three-dimensional maps of these elusive plasma structures. Understanding their shape, density, and movement could help us simulate their origins and perhaps predict their future. These next-generation explorers might lead us into a new era of deep space discovery. And still, Voyager 1 sails onward, quietly fading into the dark. Its energy is waning, and its instruments may soon fall silent. Yet, even in its twilight, the spacecraft has delivered a legacy beyond anything imagined. In detecting unexpected organized plasma patterns in the vast silence between stars, Voyager 1 has done more than reveal a new phenomenon. It has shifted our perspective, redefining how we explore, what we question, and what might be possible. The journey ahead is wide open. Voyager's discovery could be the first glimpse into a hidden structure of the galaxy, a structure that will take decades, maybe centuries, to fully understand. But the search has begun. Once again, the boundary of human ignorance has been nudged outward, pushed by a small, distant traveler that was never meant to go this far, yet found meaning in simply continuing on. Voyager 1 didn't go searching for this mystery. It wasn't built to hear the universe's pulse or uncover hidden architecture in deep space. But by doing what it was made to do, persisting, observing, transmitting, it uncovered something extraordinary. That space isn't empty. It's alive with rhythm, with structure, and maybe even with meaning. As we await each new signal, each subtle tremor, each distant pulse, we're reminded that the most profound breakthroughs often come when we least expect them. Voyager 1 has touched something timeless, something immense, and in doing so, it's once again stretched the frontier of human knowledge, not through a thunderous announcement, but with a quiet message gliding across the deep. Still adrift in the ink-black void, Voyager 1 continues to astonish, not just as a triumph of engineering, but as a humble witness to the mysterious and the magnificent. The surprising plasma oscillations Voyager 1 has uncovered point not only to structured behavior in the vast space between stars, but potentially to a deeper hidden framework that underlies our galaxy, something like an invisible skeleton beneath the cosmos. What once seemed like a strange blip is now central to an evolving scientific rethink. After confirming the authenticity of these wave signals, a wave of international collaboration began. From space agencies to universities and observatories worldwide, teams are racing to understand how far-reaching this phenomenon really is. A top priority is now mapping the spatial spread of these oscillations using detailed simulations of galactic magnetism and the motion of charged particles. Are these waveforms unique to Voyager 1's current location, or are they sprinkled throughout the Milky Way, creating a kind of galactic frequency map? The challenge lies in Voyager's scale. It's like studying ocean tides by looking at a single drop of water. To widen the scope, scientists are examining indirect data sources like distortions in background radiation, anomalies in fast radio bursts, FRBs, and even subtle gravitational lensing. If similar patterns emerge elsewhere, Voyager's findings might be just the beginning. This idea has big implications for how stars are born. We already know stars form in dense, chaotic regions shaped by magnetic fields and shock waves. But what if these large-scale plasma waves serve as seeds, triggering the collapse of gas clouds? In that case, Voyager may have found more than a pattern. It may have stumbled upon a leftover signature from the birth of a star. Researchers are also exploring whether these waveforms maintain phase coherence, a steady rhythm over vast stretches of time and space. That kind of consistency suggests an underlying force at work, possibly massive galactic magnetic fields shaping and stabilizing these vibrations over millions of years. This raises a profound question. Are these waves modern events, or are they ancient relics? Fossils from the galaxy's earliest days? If so, they might serve as a kind of cosmic memory, carrying imprints of explosions, black holes, and the birth of spiral arms. It's a bold idea that space itself remembers. Just as scientists dig into Earth's sediment to read its past, future researchers may one day decode interstellar plasma to learn the galaxy's history. These waves could be the quiet echoes of epic cosmic events. The possibilities don't stop there. Some are exploring whether spacecraft could one day harness energy from these coherent plasma waves. Early experiments show that low-energy plasma can be converted into usable electricity, hinting at a future where we might surf the waves of space instead of burning fuel. Others are investigating whether the waveforms themselves carry information. Instead of binary code, data might be embedded in the rhythm and harmonics of plasma, traveling great distances without the distortion typical of light-based signals. Voyager's findings suggest that space may be full of these layered signals, overlapping yet never cancelling out, almost like music. If advanced civilizations communicate this way, we may have simply been listening wrong all along. It's even possible that what Voyager 1 passed through wasn't just a natural formation, but a constructed one, a beacon, a marker, a message. Even if it's all natural, the level of order and structure challenges the idea that interstellar space is chaotic. Physics has a name for this: emergent behavior. Simple rules at small scales create complex patterns at large ones, like the weather or neural networks in the brain. If plasma can self-organize across light years, it forces us to rethink what random really means out there. If this topic sparked your imagination, consider liking this video and subscribing for more cosmic insights. Drop a comment below. What do you think Voyager 1 has truly found out there? Thanks for joining us on this incredible journey. We'll see you in the next transmission from the edge of everything.